in the case of energy approach, we have a kinetic energy. Kinetic energy of translation is given by 1 by kinetic energy of rotational. We have done this in flywheel is 1 by 2 I into I is analogous to m and x is analogous to theta. I is called as mass moment of inertia. We have defined in flywheel integral dm multiplied by r. If you have any axis system and we have a point mass here m, and this is the radial distance equals to what? R. So this one is spinning above this point. So above this point, that is z axis, what is the moment of inertia? I is simply m into r square. This one is for point mass. Then we have discussed for ring also. Ring, thin ring. For thin ring, we have defined this equals to what? mr square. Per square. And for solid disc, mr square by 2. We want to find out moment of inertia of this rod about this axis passing through center. So this distance is what? L by 2, and this distance is what? L by 2. This end is A, this end is B, this is center. Axis of rotation is perpendicular to the given plane. AOR, axis of rotation. The total mass of this rod is capital M, is evenly distributed over the length L. The rod is uniform. Let's consider here one small point of mass equals to what? dm. Let this mass is situated at distance equals to what? x. Let the thickness of this one is what? dx. So m mass is distributed over L length. So is dm mass is distributed over dx. It means that dm is equals to proportion quantity m divided by L multiplied by dx. And is this mass right now at this distance equals to r, and is going to rotate about this one. So this is r. R is same as x. So is the moment of inertia is given by integral dm. Dm is what? M by multiplied by dx. And multiplied by what? R square. R square is what? X square. Is it multiplied by dx? That is this quantity. And this rod has variation from A to B. Now since I fix up my axis at this point, is this quantity is x equal to minus L by 2. This one is x equal to 0. And this one is what? X equal to L by 2. So your limit is minus L by 2 to L by 2. So we can solve this. This one is capital M divided by L, integral of x square, x cube by 3, x cube by 3 equals to minus L by 2, upper limit equals to L by 2. You can put this back. You will get M divided by L. This 3 will be as it is. First term is L by 2 cube. L by 2 cube is L cube divided by 8. This sign is minus. Second term is also minus. So this one is minus, and again minus of L cube divided by 8. You can solve this and you can check out. Your answer is ml square by 12. Now if you are interested to find out moment of inertia about this axis, so I will change my axis of rotation. I will write this one is axis of rotation. So I normally remember moment of inertia about centroidal axis because these are all standard value, and we can transfer this to another axis which is parallel to the first axis. Using parallel axis theorem, which says that I is equal to IO plus mass multiplied by perpendicular distance square. So we can use this formula. Now this one is IA. Moment of inertia about this centroidal axis is ml square by 12. Mass is m. You have to take entire mass. And distance, d is not diameter. Distance is this, L by 2. L square by 4. And you can solve this. You will get ml square by 3. So we have a mass here. So this mass possesses what? Kinetic energy of translation. And if we have a disk, or we have a solid disk or thin disk, then it will possess what? Kinetic energy of rotation. So whenever you find disk, it will be equals to what? Kinetic energy of rotational. When you find mass, we have kinetic energy of what? Translational. But when you have a disk, and disk will go this way also and will rotate, that is a rolling motion. So it has both kinetic energy of translational plus kinetic energy of rotation. When it is pure rotation, no translation. But when it is roll means what? Translational plus rotational. So it's a combination of both. So you have to first check the figure and to see the movement of disk. In case of spring, we have potential energy and is given by 1 by 2 k time x square. So how this energy comes? So we have the force versus delta diagram, displacement diagram. And it is known that force is proportional to what? Delta. If you don't have any displacement, then your force required is 0. This one is famous Hooke's law. And in the flywheel we have done, work done is equals to integral T d theta is same as integral F into dx. So at any distance x, your corresponding force is what? This force. Is it equals to k times x? And this one is displacement equal to what? Dx. So is this area under force versus displacement represents work done? Exactly similar to torque versus theta diagram. Same quantity. So this value equals to, limit is what? 0. And what is this value? Delta. 0 to delta. So this equals to integral. What is f? F is kx into dx from 0 to delta. K is outside. Integral of x is 1 by 2. X square by 2. Upper limit is delta. Is it same as this value? So this is the work done. This is basically work done. And you know that work done is same as energy. Work and energy, according to the first law, they are mutually convertible. So if you does the work on spring, it will store in the form of energy and will release it. So they are mutually convertible. This principle, according to this principle, the total energy is the sum of kinetic energy of translational plus kinetic energy of rotational plus potential energy of the spring. Does not change with respect to time. That is du by dt must equal to what? 0. Expression for natural one mass and is displaced by distance x. So corresponding translational kinetic energy for translational is 1 by 2 m x dot square. If the mass will move by distance x, if the spring is also displaced by distance x. So this one is potential energy of the spring. Is it 1 by 2 k times delta is x square. So therefore total energy is equal to kinetic energy of translational plus potential energy of the spring equal to 1 by 2 into m x dot square plus 1 by 2 k x square. By principle of minimum potential energy, du by dt equals to 0. So take derivative of this term with respect to t. First term is 1 by 2 m, we'll take as it is. What is the derivative of x dot square? Is it 2 times x dot? And then we have one more derivative of x dot, is it x double dot plus 1 by 2 k. What is the derivative of x square? Is 2 times x, and one more time derivative is what? X dot. Must equal to what? 0. In all these equations, your x dot will always get cancelled. 1 by 2 cancel, 1 by 2 and 2 cancel. So do you left with the same equation as m x double dot plus k into x equals to 0. Can be written as x double dot k by m multiplied by x equals to 0. And therefore this term is what? Omega n square. So omega n is under root of k by m. Now this in entire calculation I have not considered the mass of the spring. But if I given the mass of the spring equals to, naturally that will also influence my vibration. So this equation is for which mass spring or without mass spring? Without mass spring. So you write down here neglecting mass of spring. What is the difference now? Is this mass? Now we have two masses. One mass is this mass and is this mass is pointed mass. But is this mass is uniformly distributed over the given length. So we must know what is the center of mass, and then we can apply the concept of what? Kinetic energy of translational. So we have one term of kinetic energy of translational, or we have two terms of kinetic energy of translational. We have two terms of kinetic energy of translational. One for this mass and one for what? Mass of spring. This spring of mass equal to ms, let assume that this is moving downward with a velocity equal to v is equal to what? X dot. Now this mass ms is distributed over the entire length, so I will consider one section. So let's consider one small section here at a distance equals to what? X, and thickness equals to what? Dx. Taken in the case of rod also. The ms is distributed over the L. Ms is distributed over the length L. So can we calculate this small length mass? So the mass for this small thickness is dm is equal to m divided by L multiplied by dx. Now this end is moving with the velocity v. This end is stationary. Is the velocity is linearly varying from this point to this point. So what is the velocity of this point? Velocity of this point, that is this section. So velocity of this section will be in proportion to this v. Is depend on length L and distance x. So at any point your velocity is given by v multiplied by x divided by what? If your x is 0, is your velocity 0. When x is 0, you are on the free end, fixed end. So what is the velocity? 0. When x is equal to L, are you on free end? Is the velocity is v. So what is the velocity of this small mass? Is equal to v into x by L. And what is the mass of this one? Is dm into equal to what? ml multiplied by dx. Okay. So what is the kinetic energy of this small mass? Is it equal to half m into x dot square? So this equals to. I will go for integration because I want entire quantity. So I write integration. This is 1 by 2. What is the mass of this element? Is it m by L multiplied by what? Is the velocity square? What is the velocity? Is it v x by l? Is it whole square? And is the limit is from 0 to l? So is it a kinetic energy of spring now? Why we consider the spring kinetic energy? Because the spring has mass. Previously we don't have a mass, so that's why we neglected it. So this one is kinetic energy of the spring. Let's solve this. The constant for this one. 2 common, m common, v square, l square, l cube. 1 x square is left. Integral of x square dx. Integral of x square dx is what? X cube by 3. Is it L cube by 3? And L cube cancel out. Only thing that we'll write like this. Is it 1 by 3 into 1 by 2 into mass of spring? I will modify my letter. Is it multiplied by v square? Now this is kinetic energy. Next time you want to remember this equation, you just make 1 by 3. We have two kinetic energy, one for spring and one for mass. For mass, I have written like this, plus spring I have calculated right now is 1 by 3, 1 by 2. Is it ms multiplied by x dot square? Any change in potential energy? No. But we have additional term here. 1 by 3. Now derivative of this one is 1 by 2. M. Derivative of x dot square is 2x dot into x double dot plus 1 by 2 into k into 2x. What is the derivative of x? X dot plus 1 by 3 into 1 by 2 into ms. X dot ka derivative is 2 x dot. Is it x double dot? And is this total quantity 0? Now cancel out common term. 1 by 2, 2 common. 1 by 2, 2 cancel. Now 2, 1 by 2, 2 cancel. And even your x dot always get cancelled. Remember this, huh? Your x dot always get cancelled. X dot, x dot, x dot. So what is left? mx double dot. Is it ms by 3? ms by 3? And this one is common quantity for x dot. So I will keep it one bracket, and this one is x double dot. Is it plus k into x? And therefore our standard equation will take form of what? X dot plus k divided by m plus ms by 3 into x equals to 0. So if you take the under root of this one, is it your natural frequency? So natural frequency is k upon m plus ms by 3.